All right, so here's part 2 of the 2.4 notes. Last thing is just what the last part of the objective. So the first 3 objectives are in the first part of the video. This is the fourth objective. Talk about the factor theorem. We never talked about the factor theorem explicitly last year, but we did talk about it in theory. So the factor theorem states if f of x is a polynomial, all right, if f of c equals 0, then x minus c is a factor of f of x, meaning if something has no remainder, then it is a factor. This is looping in remainder theorem, right? Because if f of c equals 0, that means when you divide the polynomial by x minus c, then there'll be no remainder. So we're going to use synthetic division to prove or to get an answer when we look at some examples. Basically, if it's as simple as this, if you get 0 for the remainder, it is a factor. If you get anything else as a remainder, it is not a factor. Okay. So the first example here says solve the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of that. So this is not necessarily proving whether or not like x minus 3 is a factor or not, because it's telling us that it is, but we're going to use that fact now to then do synthetic division and see what the result is. So we already know that x equals 3 is one of the solutions because it tells us that here. We're going to use that fact in synthetic division with 3 as the divisor. So then 2, negative 3, negative 11, and 6 are going to be, oh, that line was too close, are going to be the coefficients. All right, so let's do synthetic division. That's not much better. Anyway, drop the 2 down. 3 times 2 is 6. Add down, you get 3. So this synthetic division is no different than it normally is. 3 times 3 is 9. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. And you add down, you get 0. That's what we would have expected, given that 3 is a 0. We got 0 as the remainder. Now what's left over is 2x squared plus 2x plus 3. The solutions of this quadratic are the other 2 solutions of the original equation. So I'm going to try to solve it or factor this by, or solve this by factoring. Oh, that's not plus 3. Hold on, I wrote that equation all wrong. That should be plus 3x, and that should be minus 2. Because whatever I just wrote was not factorable. This, I think, will be. So now when I try to factor this, I'm just going to try to unfoil it. If that's 2x squared there, it's going to be 2x here and x here. Negative 2 means it multiplies to negative 2. So I'm going to do plus 1 here and minus 2 here. No, plus 2 here and minus 1 here. Right, because I foiled this back together. 2x times x is 2x squared. 2x times 2 is 4x. Negative 1 times x is negative 1x. Add that together, you get 3x. Negative 1 times 2 is negative 2. You could also factor this using the MUDS method, right? So the MUDS method would have worked there as well. To me, it's easier to not do that, but you can still do that if you want. Now you just take each of those factors, 2x minus 1. So if that equals 0, that means you add 1, and you get 2x is equal to 1. So you get x is equal to 1/2. Here you have x plus 2 equals 0, so that means x is going to equal negative 2. So that means the three solutions are negative 2, 1/2, and the 3 that you started with. Okay, so I want you to try this one on your own. So you can pause it, try it, and then see if your answers match up with mine. So the first thing I did was I did synthetic division, given that negative 1 is already one of the zeros. Worked it out, got the 0 remainder. Otherwise, that wouldn't have made sense. You end up with 15x squared minus x minus 2. I factored it and then set each of the factors equal to 0 and got 2/5 and negative 1/3. So that means the three solutions to that original equation are the negative 1 that was given and the 2/5 and the negative 1/3 that we just found. All right. Let me know if you have any other questions.